Most frequently most frequently used features are the surface based features. You can access these features through this toolbar, sketch based features toolbar, or you can also access them through insert and go to sketch based features. The first command that is there in the sketch based toolbar is the pad command. By pad command you can extrude any sketch profile in a normal direction or in any direction. I have the sketch is a simple rectangle and in the XY plane, so I'm going to extrude this sketch in the normal direction, that is Z direction. So I selected this sketch. Here's the limit, first limit. If I say 50 mm, so this is the distance by which it is going to be extruded. So here we go, this is extruded in the positive Z direction. What if I want that to be extruded in negative direction as well? So I will click on more, and here I see the second limit. The second limit is the limit 2. I can enter that distance whatever I want, let's say 35, and it is extruded in the negative direction as well. If I click on mirror extend button, so the first limit will be equal to second limit, so it will be actually mirror across the sketch plane. So here we go, this is 50, this is 50. By default, the direction of extrusion is normal to the profile, that is normal to the sketch plane. However, if I had any inclined axis or anything, I could select that as well, and the extrusion would have been along that direction. So I click on I can click on preview to see how it is going to be extruded. I can click OK to execute the command. In the pad command, if I can edit this command from the tree. If I double click, this pad definition dialog box will open, and here I see this thick option. By thick option, I can give thickness to the sketch. Like if you see, if I select thickness 1 as 5 and thickness 2 as 2, and if I say preview, you see this sketch is not only extruded in the Z direction but also in lateral directions as per the thickness parameters that are given here. So thickness 1 is outside, sorry, thickness 1 is inside thickness and thickness 2 is the outside thickness. I can also reverse this direction. If I click OK, this command will be executed. However, right now I don't want this, so I will I will have the normal pad element. Now let's see the pocket command. Here is the pocket button. I have this sketch. It's a square. Now I'm going to remove material from this slab. So for that purpose I will be using this pocket command. I select this sketch. You can also select this sketch from graphics or from the tree, model tree. By default it has taken the direction in the downward direction, but it is wrong. I can reverse this direction either by clicking on this arrow or by clicking on reverse direction. I can enter the distance as 30. So you see this is how the material will be removed. However, if I want a through cut, I could use this option in the up to last. Then this, I don't need to worry about the distance, it will be automatically taken. And if I click OK, this will be a through cut. Now in the pocket command, if I had used this thick option and if I had entered such parameters, the 2 mm and 3 mm as the thickness 1 and 2 respectively, then this will be the thing. It has removed the material from the around the profile by the thickness parameters that I entered. Okay, so now I'll see the next command, which is shaft command. For that, before that I must deactivate these two elements. For shaft command, I will click on this shaft button. I have this shaft profile. Let me show you first. This is the profile. This is an open profile. This is because the axis which around which I am going to rotate this profile is coinciding with this endpoint. So that's why I could keep it as an open profile. However, for any 3D command to execute, I must have a close profile, like I had the close profiles in the earlier commands, pad and pocket commands. I had all of them, like the rectangles and the square, they were close. So however, in this case I can use the open profile. I select this sketch, I select this axis, y axis, or I could also select z axis from here. And then this is the first angle. If I select this as 120, if I enter 120 as this first angle, then this is how the limit will work, first limit will be. And if I enter 60 as the second limit, then it will be along this direction. Right now I'll keep it as full circle, so I will enter the first angle as 360 degree and I'll click OK. So here's the shaft component. Now what if I want a groove in this shaft component? I could use this groove command. For the groove command I have this profile. Now note that this profile is a closed profile, as the axis around which I am going to rotate this profile is not coinciding with this profile, so that's why I needed to keep it as a closed profile. So I'll click on this button groove, I'll select this profile. For the axis I will select this rotation axis, the shaft axis, and I'll select the complete angle and I'll click OK. So this is how groove command will work, should work. Now the next is hole. If I want, let's say I want hole over at the top surface, so I have first created a sketch for the point, the location. This is a point sketch that I have created on this top surface. You can see that point right here. Now I'll select the hole command. I'll first select the position, then I'll select the support, which is this top surface, and then this hole definition dialog box will open. This is the extension panel. The hole is blind, that means it is very that means I need to enter the depth. If I wanted through a hole, then I could select this up to surface option and then select this surface, or up to last will also work. However, at this point I want this to be blind. I will enter the distance as 50 mm, and then there's the bottom. I want to be V bottom. The tool angle is 120 degree. The normal to surface is the direction. Then I'll go to the second panel, which is type. In this type panel I can select the whole type, whether it is simple or counterbore or countersunk. I have to enter these additional parameters. Enter it as 5 or 10 as the depth. And then the next panel is the thread definition. If I want a threaded hole, I can also use I can use this panel. I should pick this checkbox threaded, and then the type as metric thin pitch, thread, the whole dimension is 10 mm. Okay, I can the whole dimension will automatically get updated as per my selection of the standard thread parameter. So I have selected M10 as the standard thread parameter. Thread depth I want is to be 25. Hole depth is of course 50 mm, and which I have already entered in the extension panel. And now I'll click on OK. So here is the hole. Now we'll see the next commands, which is rip command, and then slot command. First of all, the rip command. Before that, I should deactivate these commands, these elements. Okay. For rip command, I have a profile right here. This is the rip curve, and this is the rip profile. So basically, I'm going to create a hollow pipe This is the rib profile. This is a hollow pipe profile, and I'm going to extrude this profile by this guide curve. So this is the difference between rib command and pad command. In pad or shaft command, we don't have any access to set any guide curve. It will be the sketch or profile will be extruded in the normal direction, or as in the shaft command it will be extruded around the axis of rotation, that is circular. However, in this rib command or slot command, we have access to set any guide curve. So in the rib command, I am selecting this as the profile and this as the center curve or guide curve, and if I click on OK, so this is how rib command works. I have second rib profile as well, second rib as well. So this is the curve for second rib, and this is this is its profile. It's same as for the first profile, however the location is different. So again, rib button, rib profile, rib curve, guide curve, and if I say OK, so this is how the second rib will look like. However, there was one more option over here, merge rib ends, merge ribs ends. If I had selected this option, then see what happens. It has not only it has extended the rib extrusion to the nearing solid element, and if you see from inside, this has not only extended but also trimmed the inside part, whichever was coming inside the second rib. So if I click on OK, this is the difference between using this option and leaving and not using this option. Okay, the next command is the slot command. Let's just first deactivate these elements, and for rib command, as it is a material removal command, I need something solid, so I'll activate this pad command, pad element, and there is a slot curve on this profile and this slot profile. So basically I'm going to remove some material from this slab as per this profile and as per this curve, along this curve. So slot, but I clicked on slot button, I selected this profile and selected this as guide curve, and I click on OK. So here it has removed the material as per the parameters that I gave. So these are the important sketch based commands that are more frequently used in the part design workbench.